Right, in this tutorial what we're going to do is take a look at the solution for Arduino task number 2, which is involving the introduction of switches. Hopefully you've logged into TinkerCAD, you've opened this resource before you start, and you know you've got the right one if you've got some code down here at the bottom. I think what we'll do is probably, before we do anything, let's just click on Start Simulation and look at how it works at the moment. So the simulation is running, there it is, this LED is lit. There's a switch on here, and if I push and hold down that switch, LED goes off, and if I take my finger off it, the LED comes back on. So let's unpick that a little bit and look at what sits behind it. Let's hide this away and just talk first about the circuit. So what we've done is, one of the nice things with Arduinos is they give you access to power whenever you want it. So all of these ones here, the pins that we used before, with these, what you would have is you can control when these get turned on and when they get turned off. And down here at the bottom, we've got a couple of things that are quite useful to us. We've got this one which we're using that says 5 volts, and anything you connect to that has always got 5 volts coming out of it, as long as that's plugged in. And so I've run a wire from 5 volts, and I've run it along here, and I've dropped it into this bottom row on the circuit. So if I ever needed 5 volts for something, in a minute I'll show you where I want that, I can connect here and I'd automatically have that. What I've also done to keep it close by is, a lot of the times with the circuit you want access to the negative end of the battery, or ground as we like to call it, and there's access to ground here. There's also access to ground here and here, but there's one here, and so I've run a black wire and I've connected it up there so that if I ever want ground, I've got it there. So I've got power along here, ground along here, and that's going to come in handy a bit later. What else have we got? Well, if you solved the previous tutorial, this will hopefully feel quite familiar. We've got digital pin number 3 here, and I've connected that with a wire to this this column, so it's here. So that will allow the electricity, when this is turned on, to pass through that resistor. Don't forget there's a gap in the middle, so the resistor then jumps over that gap, continues up here to the positive leg, the anode of my LED, pass through the LED, and it comes back out through this black wire down here, and as we said a few moments ago, that will take me off to ground. So that will allow me to turn that LED on and off. The part that's new here for us is this little switch. And the way you have to understand the switches is that a switch is effectively made with a couple of pieces of wire. One of those pieces of wire is here. Okay, so that if you imagine, if I snap this open, don't do that, it's destructive. If I snap this open, in there's a single piece of wire that runs there. There's one end of it, there's the other, and you can't see the bit that's in the middle, but it's there. Here's the second piece of wire. It runs from here along to here, and if you think about it, that piece of wire and that piece of wire, they're not touching. Okay, so at the moment, as we look at this, that wire there and that wire there, they're not touching. So how does a switch work? Well, at its most elemental, a switch effectively is simply a piece of wire that you've either cut and the two pieces of wire aren't touching anymore, or you bring them back together so they're connected so that current can flow through them. Electricity can't jump over gaps, not unless you've got a lot of voltage, like lightning or something like that. But in general, the electricity won't jump over gaps. So what happens inside a switch is, underneath this button, underneath this circular part that you've got here, hovering just in empty space, is a third piece of wire. And that third piece of wire runs sideways like this. So the way the switch works is, when you push down on the little plastic button, that pushes the wire down so that one end of the wire touches this piece of wire and one end of the piece of wire touches that piece of wire, and it bridges the gap between the two. At that point, electricity can flow through it. Let's take a look at how that works in practice here. So we've got this green wire, we've connected that to digital pin 12, and we've said before that pins can be inputs, so they can receive information from the outside world, or they can be outputs, like they can turn things on and off. Well, this time I'm going to use this for an input, and all it's doing is it's going to be listening and sensing whether there is the presence of a voltage here or whether there isn't. So if there's no voltage, it would say that that pin is low. If it detects that we're sending a voltage there, it goes high. So looking at the circuit again then, you remember I said we've got 5 volts just here, 5 volts all the way along here. Well, as it happens, I've also got 5 volts traveling here and arriving in this row. So when the 5 volts is there, when this circuit's plugged in, if you've got a multimeter or a voltmeter or anything like that, and I put it on here, I'd be able to measure 5 volts. And we know that's all one piece of wire. I'd get 5 volts in any of these as well. But what I wouldn't get is any voltage at all just here, because this isn't connected to this, okay? When we push the switch, that allows the voltage to flow along that little piece of wire that's in there, and then 5 volts also, as long as we're holding the switch down, is present here. And that 5 volts will flow along this wire, down here, and that's going to go into pin 12. So when we push down the switch, 5 volts is here, that goes high. When we take our finger off the switch, there's no voltage arriving there, and it goes down low. The last little piece of the mystery is this guy here, this 10K resistor. And for what you're going to do in the lower school, you don't need to worry too much about this. But the best way to think about it is this acts a little bit like a, what's a good way to put this? Think of it like this. When you turn this off, just here, then there's all sorts of other circuitry inside this Arduino Uno, and it generates its own little bits of voltage and bits of current happening all the time, thousands of times a second. And it's possible that this pin might, if we didn't have this here, get some funny ideas about whether or not it was turned on. By having this resistor here, it just means that there's a connection from that pin through that resistor down to the ground pin, down to 0 volts, down to the negative end of the battery. And so making sure that we have a resistor here just ensures that the switch will work. You don't need really at this stage to understand it too much. Just take my word for it that if you don't put this resistor here on the same side of the switch that this is on, it won't work properly. Okay, so just put it here for now. If you do GCSE, do A-level, we'll talk about it more in the theory lessons. Okay, so let's have a go now at looking at the code. So in the code, what we always say is that we have 2 stages in our code. We have setup, just like we had it before. It runs once and once only when the code first starts up. And then you've got your main loop, which is here. And we've said before that we start at the top, work to the bottom, back up to the top, work to the bottom, and it just keeps running through the instructions we put in there over and over again as fast as it possibly can. And that's pretty fast. But we've got some other stuff in here now. We've got these lines that we haven't seen before. Now, what's going on here is because the Arduino is much more powerful, it gives us the ability to create variables. Maybe you've done that in Scratch before, maybe you've done that before in Python, in a computer science lesson when you've done some coding variables. And variables really help us out when we're writing code for this type of stuff. So let's look at the variables that I've created here. Now the first one I've got is I've told it that I'd like to make an integer. So an integer is a whole number, and I'm going to call that button pin, and I've given that the value of 12. The word const at the top, I didn't really have to put that there, but all it means is that's me telling the Arduino chip that I'm never going to change it. So this is going to be set and it won't change. So I've got an integer, I'm calling it button pin, it's worth 12. And indeed, if you look here, the button, or the switch, is connected to pin 12. So it's just a nice shorthand way of remembering where I'm keeping that. I've created another one which I've called green LED, and I've made that worth 3. And if you look here, look, there's pin 3 connected to that LED. What I've then done is I've added one more variable, and what I'm using there is I've called that button state. I've made that worth 0. And all I'm doing with that is I'm simply saying that I'd like to be able to remember what the button's doing, and I'm going to say that 0 means off and 1 means on. So by default, I'm going to set that to 0. I can then use these anywhere I like in my program in future. You notice this one's not a constant because the button state's going to change as we go along. In my setup, I've got pin mode. We've used that previously, so I've said that the green LED, pin 3, is an output. We're going to be turning that on and off. And I've also said that the button pin, pin number 12, is going to be an input because that's going to send in information from the real world. Okay, the main program then. In the main program, what I've said here is that the first thing I would like it to do is to make the button state variable be worth whatever the button is currently doing. So digital read simply means go and have a look at what that pin is up to, and then give me the result. It'll either give you 1 for on or 0 for off. So we're going to have a look at button 12, and that will be 0 or 1. We then use an if statement. You'll have used these before in Scratch and Python and maybe Circuit Wizard as well with those diamond shapes. And I'm going to say that if the button is on, then, that's what's happening here, then I would like to turn the LED off. Otherwise, I'd like to turn the LED on. And it goes back to the top and it reads the button and it goes through that simple process. So what's the button doing? Act accordingly. into the challenges then. So the first challenge says change the code so that the LED lights up when the button is pushed and turns the LED off when the button is not pushed. Okay, let's take a look at that. So nothing here is going to change because I've not changed my wiring. The setup, again, nothing here is going to change. So whatever I'm going to do, that's going to have to change down here at the bottom. I'll still need to read in what the switch is doing at the start of each loop. So I think that whatever I'm going to do is going to have to get changed down here. So at the moment I've said if the button is on, the LED goes off. It needs to be the other way around, doesn't it? I want it so that if the button is on, the LED goes on. So let's try doing that. And I also need to give it the ability to turn it off. So maybe this else down here becomes a 0. I could do something like that. Okay, let's click go and see what that does. Okay, so we're running now. LED is off. I push the switch. LED goes on. Perfect. Really nice. There's other ways I could have solved this as well. I could have done it perhaps without this. I guess what I could have done is to grab this line of code, pop it up here. There's always multiple ways you can solve a problem. One of the things I really like about code. And what I then could have done was going to cut this temporarily. Is I could have changed this, and I could write in here button state, couldn't I? Because I'm saying that I want the green LED to do whatever the button's doing. The button's 1 or 0. That's a 1 or 0. This would have worked as well. Like that. And fewer lines of code, which is nice. However, for what we're doing today, we're going to be using a bit more of this if type stuff. So I think we're going to want to keep that. Okay, problem 2. Let's keep going. Okay, make the LED flash when the switch is on and be turned off when it's not pushed. Tip, you might need to use a delay. Ah yes, we used these guys before, didn't we? Okay, so make the LED flash when the switch is on. So as before then, no need for more variables. We'll still need to store the button state somewhere. The setup's not changed, so we're down here at the bottom. So we're going to say, read the button state, that's fine. And then if the button is on, comment's not really accurate anymore, is it? Let's get rid of that. Get rid of that one as well. Okay, so if the switch is on, we'll turn the LED on. To make it flash, we've got to turn it on and turn it off, turn it on, turn it off. We have to do that. And there was a hint up there about using a delay, so I'm going to grab one of those. That seems okay. So I'm going to turn it on, wait about half a second. And I think I've got to turn it off because that's how we solve this problem in task 1. And then we'll have another little delay in there, like so. A few people I've heard in the past have said, but what you need to do is to grab that and then copy all of that and then paste it underneath there a whole bunch of times and do it 5 or 6 times to make it flash. I can understand why you'd think that. But if you remember, the way that this works is as soon as it's run this lines of code, it's going to jump straight back to here, a fraction of a second later, read the button again, and it's going to make it flash another time. So in reality, you only need to say it once, and it will keep doing these commands so quickly, one after another, that you'll get that nice flash effect. Let's check it out. There it is, LED flashing away. Right, another one done. Okay, next one. It says add a red LED to your breadboard connected to pin 5 on the Arduino. Okay, so we'll turn the code off for a sec. LED, stick you in about here somewhere. That LED is red, that's going to need a resistor. And just like before, I mean, we can use this as a template for how we're going to do this, really. So I'll pop that there. It's a slightly different resistor. That's okay. I'm going to change that to be the same. It'll still work if you leave it like that. I'm going to change it, though, so they match up. And it's actually a 330 ohm resistor, is that one. I need a wire running from output 5. It's going to connect up into here somewhere. It's quite nice to make the color, the wires all the right color. So I'm going to color that there. A little double click on here just to tidy that up a bit. Looking good. And then one more thing left to finish that, which will be a way. So the power is going to flow up here, up here, through the resistor, through the LED, out the other side of the LED, and then from there it needs a connection to the negative end of the battery, which is that one. Colour that black so it looks right. There we go. Right, that's the LED added in. Okay, will it start? Will it run? Will it light up? No, it won't. I wonder why. We'll find out next. Okay, so next one then, that's on pin 5, right, done. Next one, add a line to your setup code so that the Arduino knows the LED is there. Fine. So the setup code is down here. I guess I can copy and paste this line. I'm going to call this one red LED this time, I think. And I wonder if I try and click play on this right now, I wonder if that's going to work. Would the Arduino be happy with this line? I think it would. Would it be happy with this line? Let's find out. Okay, I've got an error, and it's told me, I look down at the bottom, it says error, red LED was not declared in this scope, suggested alternative green LED. Okay, let's just close that for a second. So why, I wonder, is it grumbling about this? Well, the reason is that red LED is just a word that I invented a second ago. I've not told the Arduino what that means. If you think back up at the top, I described what I meant by green LED. I said it was a number and that the number was worth 3. So I need to add that on here and make that worth 5. So now it will work. Will it make the LED turn on and off? No, it won't grumble anymore, but will it make it flash or turn on or do something? I think, oh, okay, yeah, sorry. To make sure I give it the right name. As I was saying, the code will run now, and the green LED will continue to flash, but the red one's not flashing as well. I wonder why. Let's keep looking at the code. The next one then, add a line to your setup. I've done that. Add a line to your loop so that when the button's not pushed, the red LED is on, the green LED is off, and that when the button is pushed, the red LED is off, the green LED is on. Okay, right. So button not pushed, red one on. So we're going to have to do away with this idea of making them flash, so that can come out. Okay, button not pushed, that's this code here. And we're going to have to use something like a digital write, I suppose, because that's how we control the LEDs. This needs to say red LED. So button not pushed, red LED on, so that will be a 1, green LED off. I think I'm happy with that. What about the other one? Lots and lots of copying and pasting when we code. Red LED, okay. So when it is pushed, it says red LED on, green LED off. Let me just check, red LED off, green LED on. Yeah, that's fine, that matches what we're looking for. So let's give that a go. Let's click on Start Simulation. Okay, red LED on, not pushing it. Fantastic. Really nice. So I'm now controlling that with the with that little button. Right, last one, bonus question. Bonus question. Add another switch. Push switch 1 to make the red LED flash, push switch 2 to make the green LED flash, and make it a bit faster. Everything off when no switches are pushed. Okay, so for this one then, what we'll need is to start by doing some hardware stuff. Let's go and grab ourselves a switch. I'm running out of space over here. I'm going to stick it over here on this side, I think. Okay, so what do I need? Well, based on what we described at the start, one side of the switch will need to be connected to some power. So I've got some power here. It doesn't matter which side of the switch I use. So I'm going to pop that there. And we said that the other side of the switch needs to have this big 10K resistor hanging off it, otherwise it won't work. So that's going to go there. Pop that in. That's going to be a 10K resistor, I should say that. And then the last thing I need is also on this side of the switch. I need a connection to one of these pins. Number 1 looks pretty good. So I'm going to run a wire from there down in there to number 1. And let's just double click on that just to pretty it up a bit. Looking good. Okay, so what we've now got is the switch is wired in. Now what else do we know just based on our experience? We know that we've got to tell the Arduino everything that we want. So let's have a look. The button pin is currently 12. I reckon we're going to need a bit more of that. So a bit of copying there. Bit of pasting there. Now that one's already called button pin. I can't have the same name twice, otherwise the computer will complain. So I'm going to make sure that's on the right pin, and I'm going to call that something like button 2 pin, I think. And just to make it match, maybe I want to call that one button 1 pin. It's our code, we can do what we like. Okay, continuing to look down, what else is going to matter? I'll need to know which button's which, so I'm going to have this one, I'm going to call that button 1 state. And I'm going to have another one to describe the other button, that can be button 2 state. They're both off, that seems okay, let's keep looking down. There's 2 here for the output, there's 1 here for the input, so I guess we can copy that. Paste that, chuck that in there. I renamed them, button 1, button 2, so that's going to be button 1, button 2, looking good. Then scrolling down a bit more, then I'll start my main loop, so I'm going to read in button 1 state from button 1 pin. Okay, looking good. I'm going to have to read the other button as well. So you'll notice that the pattern, all I'm doing here is I'm just doubling everything up. Okay, now we get into this last bit. So I've read in what button 1's doing, I've read in what button 2's doing. I think what I'm going to end up with is a couple of these if statements that I've got here. So if button 1 state is on, we'll call which one's button 1? Button 1's this guy over here. So button 1 makes the red LED flash on and off. So that's okay, we've done that before, so it becomes a bit more familiar at this point. So that's got to turn on. Need a little delay. Go. Another little delay. Cool. Okay, so if button 1 is pushed, turn the LED on, wait, turn it off, wait, that's fine. If it isn't pushed, just turn it off. I think I'm happy with that. And then I'll have the whole lot. Nice thing is you can always add more code. Stick another one of those down at the bottom. And it's the same thing, but for button 2. So it's not going to be the red LED this time. It'll be the green one. And I think we said we wanted to make it flash a bit faster, so we'll go 250, 250, like that. Okay, I think that does everything. So we've dealt with button 1, we've dealt with button 2, we've got our little pauses in. Right, let's take it for a test drive, see what happens. Okay, so it's running, no errors, that's encouraging. Right, let's test the first one. So, red button should flash. Happy? Okay, next one, green button should flash, but faster. Hey, look at that, fantastic. And that then is how you complete the extension task and all the other tasks for Arduino button task number 2.